right now the pumps are pushing water through the system. It's falling out over there. What we're going to do now is take the differential controller and simulate it getting cold outside. And basically, right now I have it forced on. I'm going to force it to off, pretending it's gotten cold outside and it's time to drain back. So I turned it off. The pump's turned off. You can tell they turned off because it got quiet. A little bit of water is falling through there now. And you'll see a good little bit falling, and then it's going to fall back to a trickle, basically. There it goes.
There it goes.
So there's your trickle, and that's how it's going to remain, I don't know, for at least 15 minutes. I timed it a while ago, and it did that for 15 minutes at least. So that's basically how fast everything's draining back. Now, what's draining through there is all the water in the system. The reason all the water through the system is draining there is because this differential controller is controlling the pumps, and it's controlling via these wires here this actuator, which is controlling this three-way valve. So whenever the pumps turn off because it got cold outside, this thing throws the little valve such that this is closed and this is open. So now all the water in the panels, which is all the water from this pipe filling up the panels, and all the water falling from the other side back down from the panels is all being pushed through that same point. Here's the water from the bottom of the panels, here's the water from the top of the panels, all being pushed to that same point, going over there. Still here, I can feel these pipes. There's no water pushing through here. That valve's definitely closed. There's nothing pushing through. So all the water's falling there, and you can see it's still a trickle.
The reason why it's not running any faster is because there is no air pushing into the system. Therefore, there is a vacuum that's being created, and therefore there's only that much water draining out of the system at a time. We're going to now override the three-way valve.
So basically now the valve is being forced on because the charge controller is on. I mean, it's off right now, so it's in the off position. I'm going to turn it back on. So now the pumps are going to start pumping water again.
Yep, there's the water.
And the water's going to start falling out. It happened quickly because not much water had come out. And now I'm going to unplug the pump and leave this switch on. So it's staying in the position such that this is closed and this is open here. So now you can hear, I'll be quiet and we can listen. Okay, we'll wait a second for it to get pulling, but you can hear air pulling through this pipe over here.
So air is now sucking through the very uppermost pipe in the system, through here, allowing the release of that vacuum so that water can drain back through the lower line and down into the system, removing the necessity for this middle section.
And I can feel the water beginning to flow through the pipe.
And the water line is going to rise now from the bottom of the tank up and fill the system back within 10 minutes. So this is a really important reason why it is that the three-way valve is not good for a drain-back solar thermal system. We just overrode the system. We just overrode the three-way valve.
So the three-way valve was off, meaning that there wasn't water draining through the supply and the drain. So we just turned the three-way valve into the on position, which makes it so that without the pumps running, so that water is draining back through the drain and the supply. And we feel like it's going to come out pretty quick. Sounds like it's trying to. We saw the trickle. We saw the trickle earlier that it had. A lot of air sucking into there. All that air sucking in is going to get behind the water and pushing the water out. Okay, so right now these two pumps down here are on, and they're pushing water. They're pushing water up through here and through. This is a three-way valve, and right now this is closed. This is open. So water is pushing up through here, up to the panels, and then coming back through here, draining from the top and falling into the tank over there.
So the system is turned on and operational.